Welcome to the Deep Blue on My Doorstep podcast. I'm Tracy Ainsworth from the University of New South Wales. In this podcast series, we will talk to marine experts about the marine environments that we have right on our doorsteps and what we can do to help conserve and protect these blue spaces. Dr. Vincent Raoult of the University of Newcastle, New South Wales, welcome and thank you for joining us on the Deep Blue on My Doorstep podcast.
Thank you for having me.
Vince, you're a marine ecologist. Your speciality is sharks and rays, and this research, it takes you all the way from coral reefs of North Queensland to deep water in Tasmania, which means you see and work in so many of these blue spaces that we live closely with, and that means so much to the people in Australia. Do you have a blue space that's your favourite or has had the biggest influence on your research?
I enjoy all blue spaces and green spaces, and it's a bit hard. I guess, for me, the places that are special in my heart is where I grew up, which is more of a dark black space because the oceans of the North Sea are not blue and clear like they are over here. And for me, that was really what introduced me to the marine environment was spending my summers playing in rock pools and on the beaches of Brittany and exploring and discovering all these really cool little organisms that live in rock pools and playing with them. And I'd go out fishing for little prawns from my grandfather and get what's called bigorneaux, which is sea snails, which are a common food in France, unsurprisingly, and have those for lunch or for dinner in the afternoon, and so that really, I think that's looking back, that's probably what sort of kickstarted my passion for the sea. Is just spending my summers playing around in those rock pools and flying my kite on the sand and all that stuff.
Oh, nice. That's a big change from the beaches and rock pools of France through to chasing sharks in Australia.
Yes.
And I probably really need to jump into sharks because there's so much interest and fascination. Kids, young and old, are probably busting to hear about the shark side of your research.
Mm-hmm.
You work on some of the smaller sharks, little epaulets.
Yep.
You work on huge sharks that are found all the way down to 500 metres.
Yep.
You've published research on hammerhead sharks.
Yep.
That's a big change, jumping into sharks, and I know they're a huge part of your life. What really don't we know about sharks? We should know a lot more about them, right?
Well, yes. To tell the truth, we don't know much yet about most sharks, and technically the most studied species of sharks, I'd still argue, are quite poorly known. The white sharks, which is probably one of the most studied sharks overall, because probably thanks to Jaws in the 70s, which drove a lot of interest for sharks. We still don't even know where they pop. Where do they mate? Where do they pop? Those are like very key questions, and we still don't have those answers, despite the millions that have been spent tracking those sharks and trying to observe them in those situations. So if that is your benchmark for your best studied shark, you can imagine that all the other species are very, very poorly studied. So one of the groups of sharks that I study, which is saw sharks, they're actually one of the least studied groups overall, despite the fact that in Australia, quite often, if you have fish and chips, you're likely to be eating saw sharks. So the fact that these are species that are caught in abundance by commercial fisheries and they're very common on our coastlines, we still don't know much about them, and part of that is just because they live in environments that we don't really go to very often.
These are the ones you've tracked down to Tasmania and down to like 500 meters. Is that right?
Yes. Yeah. And you can imagine, waters in Tasmania from about maybe 80 meters to about almost 1,000 meters in some cases, quite possibly. It's not the easiest environment to study sharks in. And what makes this more difficult is saw sharks are very different to the saw fishes that you typically think of when you think of a saw shark. So saw fishes are huge. They can be 5 or 6 meters long and a couple hundred kilos. These saw sharks are a meter and a bit long. They're tiny little things. They weigh maybe 5 kilos max. and they don't handle stress very well, which means just to capture them, to be able to put tags on them, is a really difficult process because there's, first of all, not many ways you can actually capture them. They don't respond well to drop lines or baited hooks, which is what we usually use to capture sharks. And that means just the possibility of studying these sharks is very difficult.
Yeah.
Um, so, and that's a case of the vast majority of shark species. We have quite a few species of shark that live in those deeper environments, and those are typically the majority of shark species, and they're typically the ones that we know the less about. What we actually are able to study are typically the sharks that are, that we see diving or snorkeling, because we can actually get to those sharks.
Yeah. A lot of your research, and it uses a lot of new technology, and people probably aren't aware how much technology is now coming into science. So you do a lot of remote operated vehicles, work to trace some of these sharks and see them in their natural habitat without us kind of interfering with them. How important is technology and engineering becoming in trying to answer some of those questions about these understudied sharks?
Oh, huge. You know, the sad thing is I'm 6'4" and about 100 kilos. So me trying to swim after a shark is never going to be a good option to observe them. I'm not exactly inconspicuous.
Yeah.
That's despite me being a pretty good free diver and diver. But so really really broadened our horizons for understanding shark behavior and ecology is technology. It's exclusively technology. It's the development of acoustic tags, which are really proliferated, the development of satellite tags, which let us put these things on sharks. There's now internal tags that we can put in the stomachs of sharks to see what they eat and understand their physiology. There's tags recently that have been deployed in reproductive systems of sharks to know when they actually pup. There's shark attached cameras that let us understand their behavior in the wild. Like you said, there's remotely operated vehicles, which I've used, which are basically underwater drones. There's automated underwater vehicles, which are like torpedoes that follow sharks around to look at what they do. They're all, I use drones a whole lot. And those are all things that have let us kind of look at parts of shark lives without actually having to be there, and in many cases have really changed our understanding of shark biology and ecology, and that's exclusively technology. And that's one of the reasons that I enjoy my job, is I get to play with some very cool technology overall.
Yeah, that's a fantastic application into marine science. Do you think this link between marine science and engineering and technology will become stronger and more important to this kind of research in the future?
I think it has to. The idea, sadly, to that I have to break to quite a few of my students, is the idea that you just go out and swim with sharks and that's studying sharks. It doesn't apply anymore. That's not what we do as shark scientists. And I tell them I work more with dead sharks or with data from live sharks that I've obtained, secondhand, than I do actually swimming with sharks. Not that I don't enjoy that.
Yeah.
And this is the case not just with sharks, but with all marine science.
Yeah.
The fact is, it's really hard to actually get in the water, as you would know. Actually getting to the field and doing your work. The stars kind of have to align. The weather has to be good. You have to find time between teaching. You have to find the funding.
Yeah.
So using technology, it allows us to collect data more cheaply, effectively, and better data, arguably, is a huge step forward in science in the future. And that's why I think, having a closer relationship between engineers and scientists, and I'd argue engineers are scientists in a way anyway,
yeah,
is really important for things in the future, because those cool things like acoustic tags and like satellite tags and like ROVs, they've all become tools for research because scientists have had discussions with engineers and gone, can you make something that would do this? And the engineer's gone, I'll have a crack. And then, you trial and that kind of stuff. And so, yeah, I think technology is going to become more important rather than less so.
What's your favorite bit of kit to take out into the field, though, when you do go to work with?
Um, I think the ROV is the most fun
Yeah.
to use.
Remote.
Because you really have a little bird's eye view of of how you feel like you've peered into the system a little bit. So it's kind of like free diving, but you're a lot smaller and you can swim sideways and backwards and do all this stuff that you just can't do in person. Obviously, again, because
Yeah.
I'm 6'4".
Yeah.
Um,
Yeah.
and so that's a huge thing. Yeah, my boss Troy keeps thinking that drones are the most fun for me, and drones are cool because you can get some beautiful footage. Like
Yeah.
you just see, like there's times where I've been tracking sharks with a drone, and I'm like, that is gorgeous. Like I would just,
Nice.
I'm printing that and putting that on my wall type stuff.
Yeah.
But it's not as fun, I guess, as actually driving an ROV.
When you're tracking a shark with a drone, what's it like? You're off a boat and just following it, one that you've picked up.
Yeah,
Yeah.
yeah. So it's either off a boat or from shore,
Yeah.
and you just do search patterns and basically just do an S shape that goes on forever until you find a shark or something that you want to look at, and then you just sit on top of it and you just follow it for the flights. And it is something that requires a lot of finesse, unlike most drone work actually, because most
Yeah.
drone work, which is mapping and that kind of stuff, it's literally a question of you press your button on your control and you wait for the drone to do its thing and it comes back and land. You don't even have to touch the controls, you just have to make sure it doesn't crash into anything basically.
Yeah.
So this is the more involved aspect of drone flight.
You'll probably remember you brought the ROV in. For anyone who didn't pick that up before, it's a remotely operated vehicle. You gave me a bit of a lesson with the ROV, and what became clear really, really quickly is that I have not spent enough time gaming or playing with game consoles, and I needed.
I guess the clarification is you drive this RV with an Xbox controller, and
Yeah.
it's not something that looks like it is actually an Xbox controller.
Yeah, and I was fairly unskilled at that. It took a bit of practice, I've got to say. So for kids out there and young people coming through, I mean, some of these skills that they're getting in gaming, and you can probably speak to this a bit, they actually give you a different set of skills, a different kind of coordination that actually lets you take technology into different applications, right?
Yeah, absolutely. I mean, the way that I look at it is the way that you fly a drone or fly an ROV, pilot an ROV, whatever the correct term is.
Yeah.
It does require a different frame of mind in that you're no longer, you have to be able to displace your focus to be, okay, I'm actually somewhere else, I'm controlling another thing, I have to understand how to operate that remotely effectively.
Yeah.
And I do find, unsurprisingly, that the students that have some experience playing video games have a lot less trouble flying drones and the ROV than those that haven't.
Yeah.
And I think it's those fine motor skills, because flying those things requires really finesse. And if you go ham-fisted, which is usually what older people who haven't gained is, it just kind of they're trying to pull levers like this when they're flying, and so
and running into the side of the pool when they're learning.
you just run to the side of the pool, and it does take it is some skill. It's definitely some skill that's involved.
Yeah.
And I think that's, I mean, again, it's another cool way that science aligns with so many other things. People pigeonhole science, but actually, when you're a scientist, you need a tool set of skills that range from being creative to having fine motor skills. I mean, talking about this and flying drones, you also have picking out really tiny, doing surgical dissections on really small things.
Yeah.
Or in my case, working with very large animals that you need a crane to lift because they're so heavy. It is a suite of little skills that you need to have to do various things. And certainly for me, gaming has turned out to be a useful set of skills.
Yeah. Well, you make a good point. It's not always a straight line in science, and often it's probably better for people it's not a straight line because they do get those kind of skills. And for people, you did quite well in gaming. That was your segue along the way in marine science, and it's worked out really well for you.
Yeah, absolutely. Yeah, back in when I was a youngin, about 16, I was actually a pro or semi-pro gamer, however you want to call it, for Counter-Strike back in the day. And
That's amazing.
and that was a lot of fun, and it was I guess it was something that I wanted to explore at that age, because when you're a teenager, you're not really thinking about getting a job that much. Um, and I think, like a lot of people, I didn't really know what I wanted to do at that age, and so that was just something that I was enjoying. I was like, well, why don't I do this and see how it goes?
Yeah.
Of course, nowadays pro gamers, they can make a very good living off of it, and back in my day, it was it was not the case.
Not so much.
So yeah, that's fine. Yeah. But yeah, you make a good point that the pathway to becoming a scientist is certainly not a straight one. And I know quite a few people that have had very tangential patterns with science, and I also myself in my pathway have had a very roundabout way of getting to where I am, which is why I could be a lot younger and be in the same position than I am, but I don't think I'd be as well-rounded a scientist if I was.
Yeah, exactly. I think that's a really good point, because, and you said a really important word before about science, is so much of it is creativity and combining creativity with unique skills. And the only way to do that is to go out and follow your interests and see. Yep. And see where those things align, and they could link you up with chasing sharks with drones out at Gulf reefs and out at sea. To touch back into your research, though, with sharks, what has probably been one of the most surprising findings that you've had through your shark research?
There's so many things, so many moments that I can outline that were awesome discoveries. So for my PhD, for example, I was looking at trying to understand aging in sharks to some degree, and the way you do that with sharks is by looking at vertebrae.
Yep.
And we were at the Australian synchrotron of all places, zapping our shark vertebrae with high energy X-rays in like almost sci-fi type conditions, and we had the first results coming up, and we just it was like a eureka moment where we're like, oh wow, the calcium patterns don't really align with anything, but strontium is coming up with all these really cool bands, and that's related to all this other stuff. And I just remember, because that was the way that beamline works in the synchrotron is you get 48 hours straight. So you sleep on site and you have rotations, and so by the second 24 hours, everyone's just exhausted and like running on fumes and coffee. And when these results were coming up, everyone was like, oh, that's really cool, and everyone was like all straight away onto the screens, like having a look. And then, we were sort of aware that we discovered something cool. And I think for me, one of the best parts of being a scientist is being in those moments where you are with friends and you make discoveries, and it doesn't have to be big stuff. It's just stuff that you're interested in.
Yeah.
And and that moment, I think, is pretty unique among, I think, all professions. I don't think there's many professions where you have that moment of eureka.
Yeah.
And that was a special one. I think it was because it's probably one of the first ones that I experienced, because it was during my PhD.
And the synchrotron's a pretty special place to work and to have that happen too. I mean, it's really it's a pretty serious piece of technology for a massive building, and a lot of the applications there are medical. So
yes,
to have
have sharks. Well, that's why so the particle it's a particle accelerator, the synchrotron. It's a giant stadium almost that's all indoors, to give you a sense of scale. And we work in this tiny little portion of that particle accelerator. And everyone there is working on medical stuff. So when you tell them, oh, we're doing some shark stuff, they're like, oh, send me some. I want to have a look at it. Because the technicians are so used to working on medical stuff. They just don't. If they're like, if we see another rat, I'm gonna shoot myself. So the fact they see sharks, they're like, oh, cool. Let's see what that is. And, so it's quite. That was good fun.
Nice. That's fantastic. So in terms of the research and the places that it takes you, other than the synchrotron, you do get to get out into the field into some pretty awesome places, and you do quite a lot of research up on coral reefs and
Hmm.
sharks around coral reefs.
Yep.
In terms of that, you worked on hammerheads for a while, yes?
Yes, I did, and I
Have
still am working on I'm
you still
finishing
are?
up my hammerhead project.
Yep. And
So,
have you enjoyed it?
yeah, yes.
They're a big shark.
Yeah, no, they're quite cool. They're certainly massive. So I work mainly on the ones, unfortunately, that were again dead.
Yeah, nice.
uh, but that was a very fun project. It still is a very fun project, because I worked with some cool people that I hadn't worked with before. And again, part of the for me, the joy of science is meeting new people who are kind of like-minded,
Yeah,
because uh, a lot of people spend their lives looking for good friends, and it's like, as a scientist, everyone you meet kind of has the same joy for the natural world as you do, which is kind of cool.
yeah,
um, but yeah, that was also a cool study, which was a good story as well. The fact that great hammerhead sharks are they feed almost only on other sharks and rays, which is pretty unique among shark species. And I think they're just one of the coolest sharks.
yeah.
The fact they've got this great big cephalofoil, which is what the hammer's called, and they've got this huge dorsal fin. And they swim on their side most of the time because it's more hydrodynamically efficient.
Nice. I didn't know
You know,
that.
yeah, they're just cool animals,
Yeah.
and it's just it makes it all the more sad that they're under threat the way they are globally. So it was cool being able to work on them. I hope I
Yeah.
work on live ones at some point.
Nice. It's a good point you raise about sharks being under threat. Like, so many people are afraid of sharks. We kind of
Mm,
always think of it more in terms of the movies and us being under threat from sharks rather than sharks
yeah.
being under threat from us. But there's lots of shark species that are, like you said, globally are under threat.
Mm.
What do we need to do? What do we need to know to address that?
Uh, so a lot of people try and reduce this problem into something very simple. And like a lot of conservation issues, it's actually very complicated. So it gets reduced to finning is bad. Okay, yep, finning is bad, but there's also livelihoods involved. So in Australia, we have relatively well managed shark fisheries relative to other parts of the world, and there's no finning that happens per se, even though our fishers do fin the sharks once they land.
Yeah.
So there's no live finning like there is in a lot of movies, which does happen, and it is pretty horrible. So there's that. The the problem is unregulated fishing, I would say. We have pretty good evidence globally that if we manage a fishery with good science, and it's done progressively over time, we can pretty much manage any fishery. And I really, for me, that's always a message try to get across is, I am not against fishing by any means. I'm from Brittany. I grew up eating seafood, and I think most shark biologists are, at least older shark biologists are in the same mindset. And I think culturally it's very important, and then in many isolated countries in the Pacific, for example, shark as a food source is very important, and there's no getting around that. So I think that the first thing that needs to happen is, if you have a local fishery, inform yourself about what that is. Is that sustainable? If it's not, then obviously don't purchase food that's associated with that fishery. That's the easiest thing you can do on the ground, is just don't buy stuff that's unsustainable. If it's not known that whether it's sustainable or not, then again, do the precautionary thing and don't purchase that, or encourage your local government to try and find whether it's sustainable or not. Um, but yeah, it's a very complicated issue, and it's hard to give people a straight answer in that, because it's so dependent on what
Yeah.
shark you're talking about, where in the world you're doing this and that kind of stuff.
Yeah.
But in Australia, by and large, we're doing pretty well. We have two mostly sustainable shark fisheries, with the gummy fishery in Tasmania and the Carcharodonid shark, which is like a whaler in the Northern Territories, and they're kind of the gold standard, I would say, globally for showing that you can have a fishery which is well managed overall. And that's not to say that those fisheries are perfect. They definitely can be improved, but it goes to show you can basically fish sharks without a depletion.
Yeah.
And unfortunately, what happens is, and it made the news quite recently, is you have just rampant uncontrolled fishing, like off the Galapagos with the Chinese fishing fleets, which were hundreds of vessels just on the outside of the exclusive economic zone, which is international waters, and boats can do whatever the hell they want because there's no regulations, and just fishing pretty much as all the time as long as they can, doing at sea pass transfers. So that means you have big cargo vessels, which is just giant freezers basically, and all these little fishing vessels do their thing, and then they pass the fishes onto that holding vessel when their holds are full, so they can just keep fishing. So there's no pause in the fishing; it's just going all the time, 24/7.
Yeah.
And absolutely, that's something that as a society and globally, we need to try and do something about, because it's definitely not sustainable.
Yeah.
Um,
It is a good example, though, where people can get engaged in local, make sure that their sources of fish and what's coming out of the ocean is local. They know where it's coming from. They know it's managed sustainably, and they can eat it comfortably.
Yeah, absolutely. I mean, I think the biggest thing you can do is, if you go to the restaurant, first of all, if you get fish, try and get local fish. So by local, I don't mean barramundi from Queensland. I mean, flathead from New South Wales or Mulloway or something. That's the first thing, because then you're supporting your local fishers for starters.
Yeah.
And the more value goes into that local industry, the more money there is to put sufficient management to go along with it. And absolutely, that's the number one thing. Go to your local fishmonger, ignore the salmon, ignore the barramundi, ask them, what has been caught nearby, and try new species of fish as well, because honestly, there's some really delicious fish out there that people just don't buy because it's not popular effectively. And doing that supports your local fishery. And again, the more money goes into that fishery, the more money there's for management to make sure that it's sustainable.
And that local fish caught locally fresh, it's going to taste pretty good too.
Oh, fresh fish, you can't beat it.
Absolutely. You use a lot of tech in your research, but you also research the use of technology. Notice one of your studies is looking at how we can use GoPro footage from citizen scientists, from people who are out in the environment with their GoPros and filming themselves, how that footage can be used for science. This is a really great application of people getting involved locally and also using their technology in research. Can you tell us a bit more about how effective you found that GoPro footage was for science?
Yeah, so what we did was we had footage which were just from people swimming basically, and just taking pictures, which you can do just with video footage as well with GoPro. So it's not a fancy camera.
Yeah.
And with that, you can basically reconstruct a reef, a section of the reef in 3D. And obviously for scientists, that's really useful because you can take very accurate measurements, surprisingly, from this kind of stuff. You can look at, benthic organisms like holothurians, which are sea cucumbers. You can look at coral growth and mortality and algae and things like that. And so those are all things that are quite useful to coral reef scientists.
Yeah.
And we thought we found it was quite accurate, and it's fairly simple, because all you have to do is literally get your GoPro, get it to record, and swim straight and come back, and that's it. That's all you have to do, and then you can send the footage or the images to a scientist, and then they can do something with it. So we're starting to see this a lot more, these sorts of citizen science projects, because what you'll find is a lot of people who do this kind of stuff and go swimming with their GoPro or fly their drone up above the water to look at things. They're already doing that stuff because they enjoy it.
Yeah.
And so because they're invested in the environment already, and they're producing data effectively, that video footage is data that can be used for a variety of things. It makes a lot of sense to engage more people into those citizen science projects. so that they can get on the ground and help. Basically, it's a
Yeah.
way of helping the environment. If you think about it, a large part of the science that we do, I know that it's the case for you as well, is
Yeah.
monitoring the habitats. Is it getting worse or better? That's number one for conservation um, of marine ecosystems. Is the habitat healthy or not? Is it getting better? Is it getting worse? And so if we first of all take that weight off our shoulders as scientists, it makes our lives easier because that's a big part of our work. And it can be a bit boring, basically, because it can be also soul destroying if
Yeah.
you're watching just habitats get worse and worse over time. And quite frankly, there's a lot more potential citizen scientists out there than there are actually scientists. And that means we can have a much broader, examination of the environment, get data which is potentially just as good as what we would get anyway, and make better use of our time and identify patterns on scales that we didn't before and things like
Yeah.
that.
I think you make some really good points there, because there's lots of places that people go to as tourists, and then there's the local communities that live and make those spaces open for tourists. But they're also really interested in knowing that their places are healthy or getting better or getting worse. So there's ways
Absolutely.
that community groups and that can start to engage in how do we use our time in these spaces to provide this time in a way that can be used for monitoring.
So that's exactly what we're seeing in Vanuatu, where Uni Newcastle goes every year, twice a year, normally, thanks COVID. And yeah, the locals are beautiful people, and their entire livelihood effectively depends on the health of the reef, because that brings in tourists, which is 99% of the income for those islands. Same goes for Fiji and most of the Pacific nations. And they're all, when you tell them I'm from Newcastle, the first question that's on them is, oh, how's the reef doing? What can we do to help the reef? Give us some guidance.
Yeah.
And it really makes you realize how much impact as scientists you can have when you're on the ground in those situations, and people recognize your expertise and look up to you for help effectively. And one of the reasons I love going over there is we can give that help. A couple of years ago, we identified that there was a crown of thorns outbreak that they didn't really think was a big problem. And we're like, no, this has to be number one. You have to go out there and get rid of all those crown of thorns. And they went out and they basically purged that little reef off Hideaway from crown of thorns. And since then, the reef has continued to improve in health. And it's a fantastic feeling as a scientist when you see that change, because we're so used to, particularly for coral reef science, of just having depressing stories of reefs getting worse and worse. And so when you have that positive impact, it's awesome. And when you see, locals also react to that positive impact, it's just worth $1 million. And I think a lot of scientists are trying to move in that space where they have direct applied effects that are, undeniably beneficial to everyone. And when people say the reef's not that important, or we don't care about the health of the reef, I'd be talking to those people and see what they think about that sort of term. And whether climate change is bad and all that stuff, it's like, ask them, because they'll tell you, my whole livelihood depends on whether the reef is doing well or not, and I can tell that it's not getting better.
That's a really good point. And there are people out there who need these places to be healthy, and it's so wonderful to hear your pride in having that positive impact, and just showing how making those connections between science and communities and environment can create so much for everyone involved. You've come a long way from going to sandy beaches with your grandparents. Are you living your dream?
I think so. I think so. I certainly can't complain. As you would know, being a scientist is so much more than what people perceive your job is to be. And there's certainly aspects of being a scientist that are not enjoyable, but there's also, I guess the perception of what your dream of being a scientist is and what it actually is I think very different things. And that's not to say that the dream wasn't a bad dream. And I think, I don't think if you would ask 16-year-old me if I told me that I would enjoy data analysis and coding and R, statistics and stuff like that to be an enjoyable thing. And I love it. I'd quite happily sit at my computer and do that most of the day, because again, that's where you have those eureka moments most of the time. And that's really cool. And so there's definitely aspects that I love and that I enjoy. And I certainly can't see myself in another type of job, because I love that science. I love working with people who are like-minded. I love teaching, particular, supervising postgraduate students. I think it's awesome seeing, that transition from someone who just has an undergraduate degree to a budding scientist, and see them, make those realizations of, oh, I can discover new things and that kind of stuff. That's just so rewarding.
Yeah.
And they're not stuff that if you asked me 20 years ago, what you'd enjoy about your job, they're not things that I place high on the list, but they're definitely things that I really enjoy doing at the moment.
Yeah. That's absolutely fantastic. You've got an amazing story. Professional gamer, marine ecologist, shark expert. Vincent, thank you so much for coming and telling us about your research and your life on Deep Blue on My Doorstep. It's been wonderful.
No worries. Thanks for having me.
Thank you for listening to the Deep Blue on My Doorstep podcast. Don't forget to check out our website at events.unsw.edu.au, where you'll find all the photographs from this podcast series featuring the beautiful places that we've been discussing and the organisms found in these blue spaces.